To make an inverse for secant, usually what we do is cut it off starting at 0, and then moving forward from there. You can see it won't double back on itself until you get to pi. So we can cut away this part of secant. Then the inverse secant becomes a function that can take any number that's 1 or more, or any number that's negative 1 or less, and will give you back an angle that's between 0 and pi. Of course, there's a vertical asymptote here at pi halves, so you can't get pi halves out of the secant. So that means that the secant inverse, or the arcsecant of a number, is the angle between 0 and pi whose secant is the given number x. So you're just trying to find the angle so that when you take the secant of that angle, you get the given number x. Now, again, there's not a secant inverse key on your calculator, but you can use the fact that the secant of an angle is the same thing as 1 over the cosine of the angle. So if you're looking for a particular angle, the arcsecant of x, then you know that the secant of y is x. But if the secant of y is x, 1 over the cosine of y is x. That would mean that the cosine of y is 1 over x, and y is an angle between 0 and pi, and cosine inverse is an angle between 0 and pi, so y must be the cosine inverse of 1 over x. Okay, so for example, if you need to find the secant inverse of some number, let's say you want to find the secant inverse of 3, that's not a nice number, but what you can do is you can find the cosine inverse of 1/3. Let me show you how to do that on a calculator. Let's see. If I take 1 divided by 3, there's 1/3, and now I'll take the inverse cosine of that. So I'm in radian mode, and so I get this angle in radians, 1.23. Now if that's right, the secant of that angle should be 3, which means that the cosine should be 1/3, but I know that that's the case. So if you just take the cosine there, you get 1/3, and the reciprocal of that is back to 3. So that must be the correct angle. Of course, sometimes we can figure it out just on our own. Secant inverse of 2 would be the same thing as the cosine inverse of 1 over 2, and I know the angle between 0 and pi whose cosine is 1/2 is the angle pi thirds. So don't necessarily have to use my calculator if it's a particularly nice value, which I kind of recognize from knowing the values of sine and cosine at multiples of pi sixths and pi thirds. We do something pretty similar for cosecant as well. So if you look at cosecant starting at 0, you could go all the way over to pi halves before it started to double back on itself, and you could go all the way back to minus pi halves. So typically what we do is we cut off this part of cosecant so that we'll have an inverse. Now, if you look at the inverse, it's going to take a number that's either 1 or more, give you back an angle that's between 0 and pi, or take a number that's negative 1 or less and give you back an angle between minus pi halves and 0. So the cosecant inverse of a number, or that's the same thing as the arc cosecant of that number, is the angle between minus pi halves and pi halves whose cosecant, let's see, I should spell that out, Tom, whose cosecant is the given number x. Now again, there's no cosecant inverse key on the calculator, but we can use the fact that the cosecant of an angle is 1 over the sine of that angle. So if you're looking for the angle that is the cosecant inverse of a given number x, you know that having trouble here, you know that the cosecant of y is x, which means you know 1 over the sine of y is x, which means you know that the sine of y is 1 over x. Now you're looking for an angle between minus pi halves and pi halves, and the arc sine of 1 over x is an angle whose sine is 1 over x, and it's between minus pi halves and pi halves, so that must be the correct angle. Okay, so if you needed to find, let's see, if you needed to find the cosecant inverse of some number, let's maybe take -3, then you would just find the sine inverse of -1/3. This you have a key for on your calculator. Of course, if it's a simple angle that you recognize, like if it's -2 root 3 over 3, and you're talking about finding the arc sine of, let's see, the reciprocal of this would be negative root 3 over 2. So I'm looking for the angle whose sine is negative root 3 over 2. I know that's in the fourth quadrant, and I know that's minus pi thirds, right? So I can get the answer directly if it's one of those nice values that you'll recognize from having memorized your trig functions. So let's review then our inverse functions, right? So the arc sine or arc sine of a number is the angle between minus pi halves and pi halves whose sine is x. Now the other ones that give you angles between minus pi halves and pi halves, that's the whole key, right? It's knowing what an inverse function does. An arc sine, since a trig function typically takes an angle and gives you back a number, any of these inverse trig functions are going to take a number and give you back an angle, and so the only key is to know what range the angle's in. Arctan, tangent inverse or arctan, that's the angle between minus pi halves and pi halves whose tangent is x. And the other one that goes with these is the cosecant, right? Because cosecant is 1 over sine. So cosecant inverse, or arc cosecant of x, is the angle between minus pi halves and pi halves whose cosecant is x. And then the other three that go together are the cosine inverse, the cotangent inverse, and the secant inverse. Right, so, and the other name they go by would be the arc cosine of x, and the arc cotangent of x, and the arc secant of x. Those are all angles between 0 and pi. Okay, so the arc cosine is the angle between 0 and pi whose cosine is x. Arc cotangent is the angle whose cotangent is x, and the arc secant is the angle whose secant is x. So you just got to remember that these three go together. They give you an angle between minus pi halves and pi halves, and these three go together. They give you an angle between 0 and pi. You'll always be able to find the correct angle if you're doing this. So the other tricks that we learned were, if you need to find a cotangent inverse, since the cotangent inverse key isn't on your calculator, you can do pi halves minus the tangent inverse of x. That always works nicely. If you want to find the secant inverse of x, you can use the cosine inverse of the reciprocal. And if you want to use the find the cosecant inverse of a number, you can use the sine inverse of the reciprocal.